Hey guys, Unit 2, post-assessment review. So this will be very similar to your test. However, I have either changed images or changed numbers and sentences. So let's select all true statements. It means there's most likely more than one. Dilations never increase the length of a side. Increase the length of line segments. Well, when you dilate something, it either gets bigger or smaller, or it stays. So that one's not true. Dilations take perpendicular lines to perpendicular lines. So if I were to have this shape, and I dilate it with a scale factor of 2, I'm now going to have this shape. They're still perpendicular lines. So they will continue to have perpendicular lines. Dilations of an angle are congruent to the original angle. Okay, well, if I were to have this angle, and I dilate it with a scale factor of 1/2, I now have that angle. The drawing itself is smaller, but our angles never change when you dilate. Your angles must remain the same. Dilations decrease the measure of angles. Well, we just said they have to stay the same. So that means that cannot work. Dilations of a polygon are congruent to the original. So if I were to have this polygon and I dilate it, I don't think I drew it very good. Sorry. Let's say this was a true dilation. So my angles are all the same, but are they congruent? They are not congruent. They are similar shapes because all their angles are the same, but their side lengths have changed at a proportional rate. Dilations of a quadrilateral are similar to the original quadrilateral. Well, that is true. They are similar. They're just different sizes. Their angle measures remain the same. So for number 1, you should have B, C, and F circled as correct for our review. Which pair of triangles must be similar? Triangle 1 and triangle 2 each have a 30-degree angle. That doesn't really give us enough information. Triangle 3 and 4 are both isosceles and have one 45-degree angle. C. Triangle 5 has a 30-degree angle and a 90-degree angle. Triangle 6 has a 90-degree angle and a 70-degree angle. What would the third angle be? So it has to equal 180. So we have 30 plus 90. So that means my third angle would be 60 degrees, because if I add 60, that's going to give us 180. And triangle 6, we have 90 plus 70, which is 160. So our third angle would be 20 degrees. So those aren't similar. Triangle 7 has a 40-degree angle and a 35-degree angle. Triangle B has a 35-degree angle and a 105-degree angle. So again, we need to figure out what is our third angle for each of these. So we have 40 plus 35. So those two together equal 75. The third angle, so we're going to do 180 minus 75 because that's our total, is 105. This one has a 105 and a 35. So the third angle has to be 40 degrees. So that means triangle 7 and triangle 8 are similar triangles. Question 3. Triangle ABC and DEF are similar. That means that there is a scale factor that works to go from here to here. Find the length of segment DF. So to find our scale factor, it was your new shape divided by your original. So this is our new one. This is our original. My new shape has a side length of 1 45/100 divided by the corresponding side of the original. Well, this is my corresponding side. So if I were to type that in my calculator, 1 45/100 divided by 2. So 725 thousandths. That is our scale factor. So we use to multiply from this shape to this shape. Find the side length of DF. Okay, so DF we have 4 times 725 thousandths. We get 2.9. 2 9/10. Find the side length. Find the length of segment EF, which is this one. So we're going to have 3 times 725 thousandths. And we get 2 175 thousandths. So to find our scale factor, you do a new side length divided by your original side length. And you have to make sure that there are corresponding sides. Because if you were to do DE divided by BC, those aren't the corresponding sides. They aren't the same side of the same shape. So you have to do corresponding sides. Question 4. Find the slope of each line. Do any of these graphs have the same slope? If so, which lines? Okay, well, your slope was your change in y, which is your rise, over your change in x, which is your run. You could write it as change in y over change in x. This means change. So for A, it has our triangle. So it went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Had a rise of 10 and a run of 1, 2, 3, 4. B has a rise of 1, 2, 3, 4 and a run of 2. Sorry, I did not leave that much space. You just got to write small or maybe write them off to the side and draw arrows. C, we have a rise of 2 and a run of 1, 2, 3, 4, 5. D, this does not have the points given to you, so you need to find them. So this right here is on a point, and this over here is on a point. So it has a rise of 1, 2, and a run of 1, 2, 3, 4, 5. And E, this looks like it's right on. And that one. So this has a rise of 1, 2, 3, 4, 5. And a run of 2. Second part of this question was, do any of these lines have the same slope? Well, C and D, lines C and D, both have a slope of 2 over 5. Do any other lines have the same slope? Sorry, guys, I got distracted. There's a bug in the light above me. Yes, there's another one, or another set that have the same slope. A and E. So A is 10 over 4. E is 5 over 2. These two are equal because if we were to use simplify A, or if we were to create equivalent fractions, we can reduce A by half of its size. So half of 10 is 5, and half of 4 is 2. So that gives us 5 halves, which is the same as 5 halves. And I did divide by 2. Divide by 2, I found half of each one. So lines A and E have the same slope. Question 5. Here are some polygons. So A is our original. B, C, D, E, and F. Which of polygons B, C, D, and F are similar to A? So A has a side length of 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And the diagonals I'm not going to count yet. Okay, so B, 3, 3, 3. Well, to go from B to A, 3 times 2 is 6. Is 3 times 2 4? So I'm hoping you're saying no. It is not. So B does not work. C, we have 2, 3, 2. So now we figure out, does that one work? So if we were to multiply, 3 times 2 is 6. 2 times 2 is 4. Now we have to look at our diagonal. So it was up 2 over 3. And if we want to multiply from here to here by 2, we're going to multiply by half. So half of 2 is 1. And half of 3 is 1.5. So C works. D. We have 1, 1, 1. 1 times 6 is 6. Is 1 the side times 6 4? No. So that means D does not work. E. We have 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Okay, just want to make sure those all work. This one we're gonna have to use our equation of new divided by original. So I'm gonna write that up here. This is for E. Sorry, my lights turned off. Just a minute. Oh, can I just do this? Oh, and they just turned back on. 9 divided by 6. So if we were to reduce it, we have divided by 3, so we have 3 over 2. For the other point, you have 6 over 4. Divide that by 2. you get 3 over 2. Okay, so those are still good. Now we have to figure out, is our slope the same? So this is 1, 2, 3. And this is 1, 2, 3, 4.5. So 3, and this was 2. For that side length. Now this is the one we're really going to have to look at. 4.5 and 3. So let's see. So 3/2 is equal to 1.5, 1.5. Does this equal it? It does. So that this means this is equivalent to 3/2 as well. So E works. And what about F? Looking at it, it doesn't, but we can double check. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It doesn't work. We're right. Because 4 times 1 is 4, but 11 times 1 is not 6. Choose one of the polygons that is similar to A and describe the sequence of transformations that take polygon A to the selected polygon. So for C, we would translate point T, 1, 2, 3, 4, 5, 6 down, 1 right, 1 right, then dilate using T as center and a scale factor of, and we said I got half of its size, so 1 over 2. If you choose to write E, I'm just around on the back of a different paper. So you might need to pause it so you finish writing that down. So if so, pause it. E would be to translate point, I'm going to use S because it's closest to it. And that's going to go 1, 2, 3, 4, 5, 6 units down. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 units right. I drew arrows. Then dilate using, it doesn't matter what point you use, but you do need to specify what point you're using. S as center of dilation with a scale factor of, and this was our scale factor. Remember, that's what all of them were equal to. So a scale factor of 3/2 or 1.5. They are equivalent to each other. Again, pause it if you need to so you can write everything down. And you only need one of them. So when the test does come, when it says choose one, only write one of them. If you don't have a ruler yet, get a ruler, pause it, go grab one. Draw the dilation of ABCD using A as the center and a scale factor of 1/2. So you can do a couple different ways. A ruler is what I'm going to use. So from A, I'm going to use the outside corner of A for all my measurements. A to B is 7.5. Half of 7.5 is 3 3/4. Okay, so there's 3, 3.5, 3 6/10, 7/10, and right in the middle, 7 8/10. And that is E. A to C is 7 2/10. So 7 2/10 divided, times 1/2. It's the same as dividing by 2, but we're doing scale factors, so we're going to multiply by 1/2, is 3 6/10. So there's 3.5, 3 6/10. So A, B, C, D, F. A to D is 3 8/10. 3 8/10 times 1/2. Oh man, I had to divide times 1/2. 1 9/10. So right before your 2. And this is, this is E. This would be F. This would be G. And this would be H. So I'm going to go ahead and I'm going to connect my points. That is drawn to 1/2 the size. Now we're going to draw a dilation of ABCD with D as the center and a scale factor of 1/3. So we need to do our measurements all over again because they're all different now. So we have A to D, we do know because that didn't change. That was 3 8/10, but now we're going to have 1/3. So between 1 2/10 and 1 3/10. So I need to go this way. So this would be I. So here's J. D to B. D to B is 7 6/10. 7 6/10 times 1 1/3, or times 1/3. So be closer to 2.5, but kind of between 2.5 and 2 6/10. This would be K. Now, D and C. Between D and C, we have 4 and 1/10 times 1/3. So we are between 4 and 1/10, 1 and 4, 1 and 3/10 and 1 and 4/10. So here's 1, 1, 2, 3. So in between these two. So one thing I am doing to make sure that my shapes are the same is my lines need to be parallel to its corresponding side. So I try like this line right here. Trying to make sure all of them are at the same spot on the long tick mark or along the same part of the number to make sure that my new line and my original line are the same distance and they are parallel to each other. And this would be L. They almost look like different shapes because I did the scale factor in 2 different spots, but they are the same. So show how E, F, G, H, and I, J, K, L are similar. Well, we can use that their angle measures are the same. And to do that, you can use tracing paper. On your test, you can ask for tracing paper anytime you need. So I'm going to put my tracing paper right in the corner. And I'm going to trace. Okay, so I know that the shapes are in the same size, but I can put the corners in a line. So angle for G and the angle for L, if I were to put those two in a line, my orange line from the shape is covered by my pencil and the original line is covered by my pencil. Then I can do it for the angle for H and the angle for D. Same thing. They match up. I can do the same for angle E, F, and K and angle E and J. So all corresponding angles are equal to each other, or you can put angle E is equal to angle J. Angle F is equal to angle K. Angle G is equal to angle L. And angle H is equal to angle I. I think we're on the last question. We are. Find the slope of the line, explain, or show your reasoning. So I'm going to just go from the 2 points I know. And on question 4, we talked about slope, and I wrote notes on mine. So you should write notes on yours, but we're going to write them again. So slope is your rise over your run. So slope equals rise over run. So we're going from 3-3 to 6-9. So we go up 1, 2, 3, 4, 5, 6. And over 1, 2, 3. That can be reduced. So we have 6 divided by 3, or 6 over 3, can be reduced to 2 over 1. You can write it just as 2. So the slope of the line, I would take any of these answers. They are all the same. 2 has an imaginary denominator of 1. So for each one, we're going to go up 2 over 1, up 2 over 1, up 2 over 1. Okay, that part's done. Write an equation for the line. So one thing we do need to do before we can come up with the equation, because it's not on here, is we need to find where is the origin. How far from the origin are we? So I'm going to extend some lines. I'm going to pause my video while I make my lines. Okay, so it does look kind of messy, but we need to figure out where is the origin. So I'm going to extend my line out. So if this is 3, 3, to get to my origin, I need to go down 3, left 3. 1, 2, 3, 1, 2, 3. This would be my origin. This is 0, 0. Just so we know where it's at. So B is to write an equation for the line. Well, this is similar to lesson 11 where we had to do y minus something over x minus something and make sure that it was equivalent to our slope. So we're going to have y minus 3 because we went down 3. And then x, so if we're right here, we have to go backwards 3. X minus 3. And it must equal 2 because 2 is our slope. C. Find the values of x and y. Show or explain your reasoning. So we know that when you subtract 3 from them, they need to equal 2. All right, so looking over this again and at the actual test question, the test will give you a point where you know one of them. So if it were like this point, you would have your x value is 4 and your y is x. It is unknown. And then it would give you this point up here where your x is unknown. This is your y. Your x is unknown and your y is 9, 10, 11. So then you use your slope, which is up 2 over 1, to figure out what is the unknown value. So y would be, if I were to go up 2, that gets me to 4, and I go over 1, that doesn't give me 4. I don't know how to, oh yeah, gives me 4. So up 2 from my y is 3, 4, 5. So my y value is 5. Sorry, I had my x and y's confused. And then for this one, when we're looking for our x, the x value, so we're at 6, 7, 8 over 1. So my x value would be 8. And we can go down here to the 0, 0 that we created, and we can count over 8. 1, 2, 3, 4, 5, 6, 7, I did it again. Rise is your Y. So 9, I went up 2, and my run is 1. So now let's count this out. So let's do this one first. 1, 2, 3, 4. 1, 2, 3, 4, 5. My Y value was 5. For the other one, 1, 2, 3, 4, 5, 6, 7. If I follow it all the way up, it gets me to there. D, when your Y coordinate equals 0, what is the Y coordinate when the X equals 0? So we're down here. Remember, we drew lines. I need to line up the graph below here so I can draw them. So if this is 0, 0, 1, 2, 3. Y equals negative 3. And we can plug that in. And it should work if we're using this. X equals 0. So we have negative 3 minus 3. And then we have 0 minus 3. So if I were to do negative 3 minus 3, gives me negative 6. 0 minus 3 gives me negative 2. Gives us negative 3. And negative 6 divided by negative 3 gives us 2. Good luck on your test on Friday. I'll see you guys in the morning or whenever.